Hi, this is Griffpatch. I thought I'd post a video showing the latest updates I've been making to my physics extension, which is a little bit of a playground extension, really. I don't know whether Scratch 3 will ever be able to incorporate this, but it'll be rather exciting because it's can do some really fun things with it. You can play with this extension yourself if you go to this web address at the bottom of the page here. I shan't read it out. Hopefully you can read that, and there'll be a link under the video so you can have a play. Now this is version 2 of my plugin. If you did use the previous version, you might find it doesn't work with your projects anymore because I've made quite a lot of changes since then. But let's have a little look what you can now do with this. You have to apologize for some of the icons are not quite working. That just seems to be a bit of a problem with my deployment to the Griffpatch GitHub account. So let's have a look what this project is doing. So some of this physics is very easy to put into place. What we have is we've got the main sprite one, which is my little cat. You can see let me just make this a bit clearer. All we're doing is positioning the cat at the center of the screen, setting his direction he's pointing in, and then we have the physics extension. Now that can be added to your project through this extension button down here. And you'll see I've got a Box 2D Griffpatch physics extension, which you can click on, and that will add this physics extension to your Scratch project, as long as you're running through my Griffpatch address of the Scratch 3 version, which you'll have to use for this. So that provides you with these new blocks. Now there's a lot more than there used to be if you'd seen the previous version. So let's walk through a bit of them. So what we do, we've got the positioning cat in the middle there. We're setting up the stage, and now we've got a type of stage. And the one we're using here is open stage, no floor. So in other words, there's no boundary around the edge at all. All the objects can fall straight through off the edge, and they just keep falling forever out of your view. We have an enable for block. Now what that's doing is saying I want to use physics on this sprite. So the cat is now using physics. It's enabling it for this costume, which is whatever he's wearing right now, and in mode normal. So we'll leave that like that for now. And then we set fixed, and the mode is fixed but can rotate. What that means is the cat is fixed in place on the screen. He can't fall, but he can rotate, which is what we're seeing here. He's swinging left and right. And where does he rotate around? Well, if you look at his costume, where the center of this costume is, it's just there, right on his tail. So that is where he's rotating around. Wherever I have the middle of the costume, that is where he rotates. So he's rotating around his tail. Okay. Then we have a forever loop, and we step the animation, the simulation. Now what that means is it runs this physics simulation. If I was to just take that off, stop it, can't, let me try that again, stop it. So if I run that forever loop, the physics starts working. If I stop the forever loop, it stops. Simple as that. So you need that in place for it to run the simulation, but only in one sprite. So one script must be running that steps the simulation, that does all the physics for all the sprites. If we look in the hen, what have we got in here? Let's zoom in a little bit. So we've got the green flag clicked, and then we have a forever loop inside there, and we're creating clones all the time, every 0.15 seconds, which is why they're always appearing. And in the start of the clone, we show the hen, we go to a random position at the top, like that, point in a random direction, enable the physics using the new physics blocks for the hen in mode normal, and then repeat until the position of the hen goes off the bottom of the screen, and then we delete the hen. That's all we do. That's all the whole project is doing, is creating hens and simulating, and all the rest of the interactions is done through the physics engine itself, which you don't have to worry about. So there's one example. Now let's look at a more exciting example. Let's go in for this one here, polygon. I'll just play it to start with so you can see what happens. This is a bit more interesting physics here. We have a ball, got some slopes, and we have a rather nice interaction with this physics engine. There. I really like that. showing off a little bit more funky physics. Now, the only clever extra thing in this project, rather than the other one, is that this we have a special costume here, and when I'm enabling the physics for this sprite, rather than saying enable for this costume, which looks at the costume's shape, I'm saying for this polygon, and this is a special mode that looks at individual polygons in the shape and constructs the physics object for it. Otherwise, if I quickly just show you what happens if I do it for costume instead, run that, what happens is it will create a costume as if this was a complete square. So the ball cannot go inside because it doesn't let you have, it's called convex polygons. So you can't have a polygon that goes in and then out again, which is what's happening here. So what it has to do to actually work as one object, it has to have multiple convex polygons, which means they don't go in. So these three ones are individual polygons, and they don't have any indents in them. They're just completely rectangular, and therefore, if I change to polygon mode, it looks at the three individual polygons and allows the ball to go inside, but it keeps it as one object. So that's what that was about. Let's load another example. So let's have a look at something that you'll enjoy. So scrolling. This is a funky one. So we have loads of balls, we have a donut, and we have a cat. I can press the left and right arrow keys, which causes me to rotate. And you'll notice this time, whoa, the screen can scroll, which is a bit of a big deal for this project. And I can really kick those balls around, which is great fun. Okay. So now this says enable for, and it's got a blank bit there. That's because this was a project I made before I created this new version of the extension. So unfortunately, the bit hasn't quite worked. So I should have really replaced that with that enable for this costume. All I have in here is a bit of setup. The stage is being set up with an open stage with floor, which means it's got the bottom of the level. You cannot fall off. Everything stops at the bottom, but they can go off the edge, which is what it means when it is an open stage with a floor. With a floor. I've enabled physics for the cat, and I have a forever loop here, which has got the step simulation in it, which means it's running it. Also checks for key presses, and when you press a key press, it spins with force. So the cat is told to spin, so you can spin it right and you can spin it left. The difference with the spin with force rather than the scratches turn is that this will continue to spin with physics. So it's like you spin it and it keeps going. So that's what happens. So he spins when you press a direction, steps the simulation, and then at the bottom here, what have I got? This is a right good block. Look at this. Change scroll by X. Now this is it's not really part of the physics engine, but it's something that I've added in to the physics engine library, which means that you can start to move your whole sprites around the stage without having to do the scroll X stuff all yourself. I can show you this if I just get the change scroll X by block. I just put in a value of say 10 in there. Let's just click that. Oops, stop the project first. If I click it, everything moves by that amount. So I'm actually scrolling the screen. And what's more, this scrolling is not limited by sprites going off the screen. So sprites really can go right off the screen in this version of the extension, rather than using Scratch, a normal way of making things get stuck to the edge, which is important because these, when you're scrolling around with lots of physics, you don't want them all to stick to the edge. You want them to look like they're going off properly. So that's what I've managed to achieve so far. It does the job quite nicely. So that's quite exciting. Okay, Let's look at another example. This one you're going to love, because I love it. Okay, here we are simulating a car. We have wheels attached, and we have lots of physics example interactions. We can race along, scrolls. We have a big bear. Yep. We can push things around, and of course we can crash beautifully, which is all great fun. And oh, look at that, a wheelie as well. I've never done one of those. Oh, those milk bottles. What can you do? So physics with wheels. Now this is using a very similar concept to the other project that had a rotating cat with all the hens. In that, what you can do is if I go into a wheel here, have a look at the script. What I've got here is when I get this receive set at wheels, I position the wheel on the screen, and I position it, if I run the project again, so I position the wheels in place where I want them on the screen, and I position the car where I want it, so that it's looking like a car, but without fixing anything in place, the whole thing would just fall apart. What we do is we enable the physics for this wheel using the enable for, and I've chosen circle rather than costume or polygon. And the reason for that is that if you choose just enable for this costume, you'll get a rough outline of a wheel, and it won't be perfectly circular because of the pixels and the way it works. Whereas if you enable it for a circle, it becomes a perfect circle, and it's really good at rolling. So that's what you want to do for any proper circle you want to simulate. And it's in mode precision rather than just normal. And that is useful when two objects can interact with each other that are both moving. So if there's ever any interaction between two objects that both can move, rather than say a floor that's completely stationary, that's fine. But if you need to have two things interacting that are moving, you want to put it into precision mode. Just one of the objects needs to be positioned, generally the object that's running around. It'll work without it, but not as nicely. But then, this is the important thing, the wheel, I put set fixed but can rotate, exactly the same as the cat on the chicken project at the beginning. But if you set fixed and can rotate when the wheel is in front of another physics object, it fixes it to that object instead of to the background. So the wheel is fixed to the car, exactly where it's placed. And then I set up a little bit of the attributes of this physics object. I can set the density, so how heavy it is. I set how rough it is, and I set the wheel to be really rough so it grips the ground. And I set its bounce just to normal. And then all the controls for the car are in the wheels. So we have a forever loop in the wheel, and when the arrow keys are pressed, it spins the wheel. And the same with the other wheel, exactly the same scripts, just in a slightly different position to get him on the other side of the car. The car itself, have a look what I've got in here. I set up the stage, open with no floor again. I set the scroll position to start the game, so it's not scrolling, so it's right in the center of the level. Position the car, point it in the right direction, enable the physics, precision mode again, and this is where I set up the wheels. So once I've positioned the car and got its physics set up, I broadcast set up the wheels. They position and set up their physics and pin themselves to this car. And then I broadcast go and I begin the game, stepping simulation. And all the time, I update the position of the scrolling too. So once the physics is run, I change the scroll based on the position of the car on the level so that it follows it. The most simple would actually be not to have any of this at all, just to have change scroll by X position of the car. I think that would mean it would just, the car will be right bang smack in the middle of the screen all the time. Yeah, which is what's happening here. The car is now completely in the center, whereas what I had was a bit of a clever bit of jiggery pokery here, which allows you, if you look now, car can kind of move out of the center as you race, so it actually gives you more view of what's coming, which is what that's about. So it's including the velocity, so how fast the car is going into the positioning. So as the car increases speed, it moves me away from the direction it's going in so you can see more. That's what this bit here is about, a bit of soft scrolling. But as I say, it can be simpler. You can just change scroll backs by X position. Right, so that's that game here. Let me show you some more. So we also have this project. Okay, so this one is more of a platformer. So I can walk my cat around, can jump and interact with all these objects like this. I also have the ability to fire tacos, of course. This. In fact, I can fire an awful lot of these tacos, which is mighty entertaining. And these tacos will actually start disappearing after, I think, 10 seconds or 20 seconds. I can't remember. You'll see them. Here we go. Whoa. So they can never get too many tacos. And if I go to the left here, you might notice that I have a rather recognizable structure, which of course I can either run into or I can fire my tacos at, just to prove a bit of a concept that it works. There you go. So they are a platforming type physics, which is great. Now, how does that work? There's a few extra special things going on in this one. Let's see what blocks I've used. This one here. The thing about platforms is you need to know whether you're standing on the ground, for example, for jumping. So I've introduced a new block called touching. And you can choose whether you want to check if he's touching your feet or any part. Actually, to show this example, let me load a different project up. This one, touching, is a simple example showing how the touching works. So this cat is showing you what he's touching. So at the moment he's touching stage, which means he's touching the bottom of the stage that we've set up. Let me change it down to this. If I pick him up, we'll drop him on top of this loaf of bread. It now says he's touching bread. I put him slightly off. Ooh, he's not half rocking, isn't he? Right, he's now touching stage and bread. I think what's happened is that some of my... Ooh, it's gone now. Oh, come back. Let me position him back on the screen. There he goes. There we go. So he's touching stage and bread. If I put the bread on top of his head, he now reports he's only touching the stage. And that's because I'm only saying, say, touching feet. So if I put touching any, now he's touching both again. So it tells me the cat is touching bread and stage. I change it to feet. He's only touching the stage. It's underneath that's important. Now he's just touching bread. So now I can tell what the cat is touching. It returns not just one thing, but the two things or more things that he's touching underneath as a string. So you can use that. You can then find out whether he's touching a particular sprite, and it comes up with the name of the sprite in there. Yeah, so let's have a quick little look through the blocks that I've defined so we can just know what they all do. So we've got setup stage. That's to do with how the physics engine is interacting with the whole stage. So you can have box stage, which means there's walls all the way around. Open with floor, which means it's completely open, but there's a floor that stops you from falling down further. And there's open no floor, which means there's no bounds at all. The thing just falls off out of the view. Set gravity, how fast things are falling. So if I enable that at the top of my project, run it. Okay, so that's a gravity of 10. If I stick that down to -1 instead, drop him, then gravity is now much reduced. And equally, I can put gravity the other way around. So that's great. Any gravity you like. And in fact, of course, I can have gravity pushing sideways too. That. Quickly undo that because that's going to end up with me losing all my objects. That's the one thing now, of course, I've made it so things can go off the edge of the stage, and now, of course, I'm losing things, which shows you exactly why Scratch decided not to allow things to go off the edge of the screen. However, what I would say is a good idea is that let things go off the screen, but when you hit the stop button, bring them back on again. So I might implement that, we'll see. At the moment, you can get them back generally by just clicking the go to button on each sprite, and it pops back in case you lose it. And the best way, of course, is to have your scripts set them up at the position they need to be at the beginning when you click the green flag. So that would solve the problem too. What else have we got? So enable for. So this is when you enable physics. Every object that you want to interact with each other needs to be enabled. So we've got for this costume, which gives you a convex polygon around the objects, and what that means is it fits a nice rectangle, well, polygon, not rectangle, but shape around the object's costume, and uses that for all the collisions. That's what this costume does. Circle means the object should be treated as a circle. Polygon is what I showed in the second example, is where you draw using the vector editor only the vector editor, and you do it using the polygon tool or rectangle tool. No circles or anything like that at the moment. That's how it works. And all sprites is a quick mode that just enables physics for everything that you've put on the stage, so you don't have to bother doing it to all of them. But that's really just for fun. We have step simulation, and that's used for actually making everything move. So I click this, you'll see on the right hand side here, everything moves by 1 frame every time I click that. So I always do those in a loop. We have go to XY. So this kind of replaces the motion block go to, and does pretty much exactly the same thing, except that we have this drop down too. So if I go to 0, 0, it's disappeared. Now let's find out why that is. Is my scroll set? Yes, it is. So I've actually, Scratch 3 does not reset these variables from project load to project load. So when I reloaded this project and I was scrolling around my previous game, my game level has actually scrolled. So when I positioned this in world, I positioned it in the center of the world, but I'm not looking at the center of the world. My game is scrolled to the left by a lot. So I need to reset my scroll before I'll actually see my object. There he is. So now when I positioned him, I can see him. But I have the option to say position on stage, and this works then exactly like the normal go-to. And then I also have relative, and that means move it from where it is. So it's like change X, Y instead. So now I can move it, click it, click, click. I have no idea why he's moving downwards. That's a little bit worrying. It's like he's being affected by gravity there. Or I've done something very wrong. Yes, there's definitely something wrong there. That change, I think I cannot explain that. You'll have to just not use that go to X, Y relative until I've fixed it. You'll see it get fixed if it does. I obviously haven't used that much, but it was there for an idea. It's the in-world and the on-stage that's the most important. But anyway, leave that for now. What else have we got? Where were we? So we've got the go to XY, we've got set velocity to SX, SY. So this is setting the speed that it's currently traveling at. So you can quickly just cause something. Let me run this. If I set velocity to speed Y of 10, run it. There we are. It's like jumping. So it sets his speed at that moment. And again, I can set his speed sideways or diagonally, and it just jumps around like that. So we have the change velocity, which is obviously just a way of changing the current velocity speed he's going at. And you have reporters for the X and Y velocity, so you can see how fast he is traveling at any moment. This. Okay. What else have we got? We have push with force in direction. So this is very like the set velocity, only set velocity overrides the current velocity. So you're saying he is at this moment traveling at this speed. This one is additional. So if he was already moving in a certain direction, this would add force to it. And it also is in a specific direction. So it's a slightly different way of voicing it. So if I chose an angle of -45, which is like this way, he'll be pushed in that direction. And if I do 45 degrees, he'll come back again. So that's just another way of interacting with the physics. Spin with force. So this is spinning with a force of 500. Let's do a -500. It will spin in the opposite direction. There we go. You'll have to play around with the values in there, because depending on how heavy the cat is and how much friction he's under and things, then that can change dramatically how much force you need to apply. Then we have set fixed. So I've already explained this a little bit, but you have the option of fixing something completely in place, which is this one, fixed fixed in place, that one. If I did that, then he absolutely cannot move like that. Oh, missed it. Click, there, fixed in place. So other objects can bump into him, like this piece of bread, but he will not move or rotate. That's it. He's part of the furniture of the level. That doesn't mean you can't scroll him around, because if you scroll the level, if I scroll the level by a little bit, of course the level moves, so he can move by being moved with the scrolling of the level, but he is a fixed bit of level that won't move away from the rest of the level. Alternative is fixed but can rotate. So now he's in the simulation, he can rotate around his central point. And there's free, which means he can fall around, rotate, and rotate. Set density. This is actually more than just density, it's density, roughness, and bounce. So you're kind of setting up the attributes of his physics. So this is the normal way they default to. You've got density of normal, roughness normal, bounce normal, and you've got options of very light objects, very heavy, very rough, smooth, and how much they're going to bounce around. Like if I can make this cat very bouncy, now I'll run it. Oops. Right. That work? Try it again. Oh yeah. There we go. Now very bouncy. Touching, I went over. This is whether this sprite is resting on or against another sprite. Set scroll and change scroll, so I can move the level around, and the reporters for the scroll. And that's everything in this simulation so far. So go and have some fun with it, I think is the next thing you need to go and do. There's lots of potential, and I've had a lot of fun making it. I don't know, like I say, whether it'll ever make its way officially into Scratch, and whether this version of it will. Maybe a more simplified version will find its way in at some point. But they do seem very keen on being able to make the Scratch community more involved in making extensions. So I'm quite looking forward to what might be the future for Scratch and extensions. And I think you guys probably be quite excited too. So I thought I'd quickly share this little demonstration of Scratch with physics, and can't wait to see what you guys can come up with too. If you make your projects in this extension, just note that you can save your projects to your hard drive, but you can't share them on Scratch itself. So that's just a limitation, but you can save them and load them back again using the file menu. So have fun. I hope you enjoy that extension and can get on well with it. Let me know what you managed to create. Bye now.